Good morning, good afternoon, good evening, everybody, wherever you're joining us from. Thanks for participating in our Stantec Water webinar series. My name is Ryan Murdalin. I'm a marketing director here at Stantec. I'll be your moderator. Today, we're going to talk about improving dam safety with risk-informed decision-making. Before we get started, just a few housekeeping items. First, you'll be muted during the presentation, but you can ask questions or place comments in the GoToWebinar system at any time. We will get to those at the end. We usually leave about 15 minutes for Q&A, so plenty of time. Any questions that we don't get to, we will follow up directly. I do have a way to track who's asking what questions, so we can follow up with you if we don't get to your question. A recording of the presentation will be posted to our website, usually within about a week after the session's over, for you or one of your colleagues to view at your leisure. And also send out a certificate of attendance, typically within a week or two, also after the webinar is over, that you can submit for potentially getting a professional development credit. With that, I'm going to turn it over to Rachel Bisnett, who is a senior associate in our Charlotte, North Carolina office, and she's going to lead us on the webinar today.
Thanks, Ryan. So as Ryan mentioned, my name's Rachel Bisnett. I'm a geotechnical engineer out of our Charlotte, North Carolina office, and I've been specializing in risk analyses for dams, dam safety, and dam design and upgrade projects for the last 5 years or so. So I'm happy that everybody's been able to join us today to talk about this really important topic that's one of the new buzzwords in our industry, at least here in North America. The goal of today's presentation is to help pull back the curtain on risk assessments so you have the information and confidence to make better and more timely decisions. This is really important because as an industry, we're faced with changing hazards, aging infrastructure, and increasing demands on resources that are needed to operate and maintain safe dams. Just a quick safety moment before we get started. Summer field season is upon us. As you go out to perform inspections or maybe some field investigations, take note of hazards such as biting animals and insects, poison ivy, and particularly, at least down here in the Southeast, the effects of heat and humidity. It's always best to try to avoid risks whenever we can. So, try to avoid going out at times when some of these hazards may be most prevalent. But if you can't avoid it altogether, then you take some mitigations, which are wearing proper apparel, insect repellent, drinking plenty of water, and taking breaks as needed. In today's presentation, I'm going to focus on 3 items. First, I'll give you an overview of risk to define what it is and explain how it works alongside traditional standards-based assessments. Then I'll cover some of the benefits of adopting risk principles within your dam safety program and provide examples to help illustrate the benefits. I don't plan to go into too many technical details today, so hopefully this gives everybody just a broad understanding of what risk is, how you can leverage it to improve dam safety within your program. And obviously, if you have more technical questions, I'd be happy to follow up with you afterwards. Before we get going, I'm curious to know what your current understanding of risk is. So there's a question that's going to drop into or a poll that's going to drop into the chat there with a few answers. And please take a moment to respond, and then we'll revisit these answers at the end. Many of you are probably familiar with a potential failure modes analysis, or a PFMA. Risk analyses are built from the hazard and potential failure mode identification that are developed during a PFMA. The risk analysis process is a systematic and methodical approach for estimating probability of failure and consequences due to potential failure modes. So risk is therefore a function of the likelihood that the hazard occurs, the probability of failure, and the consequences that it would occur. In this case, hazards are things like the normal reservoir level is actually considered a hazard as part of a risk analysis. An earthquake is a hazard, or a flood. There's generally 3 accepted levels of risk analysis. And the level that's appropriate for you to use is guided by the purpose for performing that analysis. So do you want to take an interim step that's just going to help you rank risks, or will you be making decisions based on the outcome? And obviously with these 3 levels, there's different amounts and details of input studies required based on the level that you select. So qualitative risk analyses use simplified tools and descriptive scales, and they're really appropriate for screening level studies and getting a relative ranking of risk, perhaps within a single dam or across a portfolio. Semi-quantitative risk analyses display the results on a matrix and give you an order of magnitude assessment of risk. And finally, quantitative risk analyses are obviously the most detailed and most labor intensive. This is where you can calculate an annual probability of failure and consequences for all levels of loading conditions, and ultimately compare those against tolerable risk guidelines to understand where you fall relative to society's tolerability. Typically, we represent risk on a plot that shows likelihood of failure on the y-axis and consequences on the x-axis. Lowest risk is in the bottom left corner, and it moves towards highest risk in the top right corner. Potential failure modes are plotted on a chart like this, so it's easy to interpret what the risk drivers are. Risk drivers are those potential failure modes with the highest risk. When we consider risk-informed modifications, we can leverage both axes to try to reduce risk. And I'll explain a little bit more on the next slide. The premise of risk-informed upgrades is to improve the risk profile for a dam. And by improve, I obviously mean reduce risk. Following a risk analysis, we have an estimate of the risk due to each potential failure mode, and we can develop options to reduce risk. So within that option identification step, you can think about structural and non-structural options. Structural options are broadly classified as physical improvements to the dam. A downstream buttress could be added to address a stability issue. Spillway capacity could be increased to prevent overtopping during a flood. And structural improvements typically affect the likelihood of failure on the y-axis. So we're moving down the y-axis generally. Non-structural options generally help when consequence reduction along the x-axis is possible. We obviously can't convince people to move out of an inundation zone, but we can increase the warning time they would have to get to safety through emergency action plan improvements or installation of early warning systems. Once options are identified, the remaining risk following implementation of the option can be estimated. This is what we term residual risk. This helps you understand if the improvement will achieve the risk reduction that's desired and is needed to evaluate the cost benefit for performing the work. Finally, the preferred approach is selected and implemented. In the traditional view of dam safety, we have binoculars focused on the dam and compliance with regulatory standards. This means, do we meet minimum acceptable factors of safety? Or is there a surveillance and monitoring program that is sufficient to assess the health of the dam? I often think of this as a somewhat binary list where you either do or do not comply with what's required. I understand there can be a little bit of gray area sometimes, but I think broadly it tends to fall into more yes or no questions. In a risk-informed view of dam safety, we take a step back and we can see the whole picture, from the hazards to the performance of the dam and the potential harm to downstream life and property. So as we've talked about, risk is a function of the hazards, the performance of the dam, and then the potential consequences coming about from that. So it gives us that holistic understanding of how all parts of this can impact our risk profile. When we shift to a risk-informed approach, that doesn't mean that we're abandoning standards. Instead, we're trying to couple the outcomes of traditional engineering assessments with a probabilistic approach to estimating how the dam will perform when it's exposed to different loadings. And we can be guided in these estimates by historical incidents. And so we still reference our understanding of factors of safety. We also, though, take into account important case studies, incidents like Teton Dam that give us a strong understanding of how certain potential failure modes can initiate and progress, and ultimately what types of consequences can occur from those. Ultimately, it's really critical to remember that understanding risk provides an additional data point for decision making. Decisions should not be explicitly based on risk, but you can consider dam safety risk as part of a holistic decision-making framework. So this involves a bit of a shift from a deterministic to a probabilistic thinking approach. So I mentioned standards-based assessments and thinking in terms of factors of safety, for instance. That's a deterministic method. We have a prescribed way to do an analysis, and then we have a acceptance criteria for whether or not we meet the minimum qualifications. When we think about it in terms of probability, we can still go through those analyses, but we can account for potential uncertainties. We can account for uncertainty in the loading conditions, so maybe the reservoir level or the magnitude of the earthquake. And we can then vary our understanding of how the performance could change based on the change in occurrence of the hazard. Now that I've given you a little more background in risk, let's walk through some of the benefits that you could see as an owner by adopting risk principles for dam safety management. I've tried to group these into three main categories. The first one is an increased technical understanding of the dam or of a potential failure mode perhaps. The second one is improvements to portfolio management. And then the third one is business case support. So what I'm going to go through next is by no means an inclusive list of the potential benefits you could see from adopting a risk-informed approach, but I wanted to highlight these because they're ones that we commonly see and commonly see owners being able to leverage. So the first one under increased technical understanding is sometimes standards-based assessments just aren't quite enough. So certain potential failure modes can be difficult to define using factors of safety. And internal erosion is a great example of this. We have ways to assess, say, heave at the toe of the dam, which gives us an understanding of whether internal erosion along the foundation could maybe initiate. But factors of safety or standards-based approaches are fairly ill-suited towards describing that full process that would be required for internal erosion that initiates to then ultimately result in an uncontrolled release of the reservoir. So when we characterize these types of potential failure modes with risk, it allows for definition across a spectrum, and that can better match our state of technical knowledge. So in the internal erosion example, we think about a pretty typical sequence of events that has to happen to get from initiation, which is where we have a flaw that exists and the erosion starts. Continuation is the next step, and that's where we consider the adequacy of any filters that may or may not be present along the pathway. We then look at progression, and that's where the concepts of there being a roof to support an open pipe within a dam, that falls under progression. And then influence of the upstream zones. So do we have a potential flow limiting zone? Do we have a potential material type upstream that as the flow now is falling into that pipe can help maybe clog the pipe and prevent that continued progression towards the reservoir? We can account for detection and intervention and how successful those may be. So is there somebody at the dam on a daily basis that you'd have a really good understanding of, or notice this pretty quickly if it were to initiate, or is it, a dam out at a remote site and maybe somebody only gets out there once a month, and so there'd be a lot of opportunity for this type of event to occur. And then finally, the dam breach that would result from this. And so when we think about each one of these steps in sequence, we implicitly assume that the previous steps have already occurred as we move on to the next one. So at the end of it, we can get an overall estimate of the probability that this type of event would happen. And internal erosion is another great example of a rapidly changing state of technical knowledge. There's been a lot of research focused on understanding different parts of this overall mechanism, and that helps us better characterize each one of these steps and have a little bit more confidence in our assessment of how those activities may flow together. The next one under increased technical understanding is the ability to prioritize additional studies. So when we do a typical dam safety review, oftentimes there's a data gap analysis that comes along with it. And that's generally driven by a list of certain studies or evaluations that should be completed for every dam. And so it could create, a list of additional studies that now need to be performed or information obtained. Maybe there's not enough geotechnical information, or piezometer data needs to be beefed up. You end up with this kind of long list of things to go do and find, and how do you identify where you should tackle it first? So through the risk analysis process, we can try to narrow or prioritize that list. And the process is dynamic. So as we complete certain studies that maybe are associated with identified risk drivers, the results of those studies can then influence maybe what we tackle next, or if the priority of that list needs to change. So it helps us better structure those studies, and it helps us have an understanding of timing and urgency with which to go collect that information. So an example of this that I wanted to share with you is from a quantitative risk assessment that I was involved in for a client in Australia. And when we first went through the risk analysis, we ended up plotting fairly high. So what this, without going into too much detail, this plot is showing you the cumulative risk. Each of the dots on it are showing you the risk from the individual potential failure modes, and the lines running across, the black lines, are their regulatory limits of tolerability. So we're above the limit of tolerability, which means we have to do something. Well, the team recognized that we had some pretty important uncertainties and unknowns as we went through this process. And the results that we assessed within the risk analysis process were definitely influenced by those uncertainties. So in this case, there were 5 key ones that I want to point out. There were 2 embankments retaining this reservoir. The factors of safety for the main embankment were marginal under normal reservoir levels. They were still above 1.5, but we didn't have a lot of confidence in the shear strengths of the soil that we based those stability analyses on. The testing that had been performed just wasn't quite within the stress ranges that were appropriate. And so, we felt that reasonably comfortable in the results, but there was still a little bit of lingering uncertainty. And we knew that there was a major stability issue with the other embankment at the site. So we wanted to just firm up our confidence and make sure that everything was okay with the main embankment. Through this assessment process, we also identified a conservative assessment of time to failure for all the internal erosion mechanisms. And what that means is once we've made it through that internal erosion process, the time that it actually takes to breach the dam comes pretty quickly. And that was based on just a lack of specific information about the geomaterials at the site to be able to more accurately assess that parameter. There was a potential unknown about differential settlement or desiccation cracking that could exist along the crest, but be obscured by the gravel road that was covering it. And then there was a little bit of uncertainty about the true filter compatibility of a transition zone that existed between the clay embankment and the downstream rockfill shell. At the time of construction in the early 60s, this transition zone wasn't officially designed as a filter. It appeared to be acting in that way, and the gradations led us to believe that, but we didn't have a lot of samples with which to base that assessment on. And then finally, there was a little bit of uncertainty about a potential depth for the differential settlement cracking. There were some benches in the abutments that would be sort of prime hotspots for stress concentrations within the dam, and that could lead to some pretty significant cracking depending on modulus values. So overall, we recommended performing a geotechnical investigation that would be targeted at honing in on things that would help us resolve the key uncertainties for the first 4 items. And then you could perform stress deformation modeling to address the potential depth of cracking. Obviously, we don't want to go digging a hole in the dam, which would be the physical way to find it, so we can do some modeling to approximate it. Well, at the point in the process we were at, doing the geotechnical investigation was really the no-brainer. It would help us firm up our risk position. It would give some good information that could be taken to the next step of the process if we needed to design risk reduction measures. And it would give us a lot more confidence in where this position plotted. Ultimately, the hope is always that you gain enough information to make a better assessment, and hopefully that comes down. But on the off chance that it doesn't, at the very least, we know that we would have better confidence of where we were. So with this list of items, we recommended to the client that we should go for the geotech investigation and defer the stress deformation modeling to the next phase of the project. It was important to figure out, but it wasn't critical for exactly where we were in the process. The final item under increased technical understanding is to better be able to target surveillance and monitoring activities. When you've gone through a potential failure modes analysis process, you often have that question at the end about, what surveillance and monitoring activities are associated with, say, category 1 or even category 2 PFMs. The idea behind using RISC to do this is very similar. So we'd like to be able to target enhanced surveillance and monitoring towards risk-driving failure modes and really supplement that general dam health surveillance and monitoring with these very targeted activities. And so an example that I think demonstrates this very well is, again, with internal erosion. Piezometers, when they are installed in dams, are a great way to understand the overall phreatic surface profile within the dam. But if you're trying to find a potential internal erosion pipe using a piezometer, it's a bit like finding a needle in a haystack. You could poke hundreds or even thousands of holes and still not quite hit that spot exactly right. to get the type of information you're looking for. But if we think about implementing a tow drain with a weir to be able to collect and monitor seepage in a controlled manner, that gives us a much better understanding of whether or not internal erosion could be occurring. We would have a visual of quality of the seepage, as well as obviously be able to numerically estimate the quantity of seepage. It's not to say piezometers aren't needed for dams, but you just need to think about the application and what your risk driver is when you're thinking about potential changes to your surveillance and monitoring program. And when we have a better understanding of the initiation and progression of failure modes, that can dictate changes also to how we perform surveillance and monitoring. So an example of a project I've been involved in where we've made an adjustment to the surveillance program is following observation of some boils in a tidal creek downstream of a dam. We obviously had a pretty heightened awareness for internal erosion and a concern about how that could be progressing. And so, there's setting aside some of the other kind of immediate risk reduction measures that we went through. Part of that process was enhanced surveillance and monitoring. And in this case, because it was a tidal area, it wasn't enough to just go out and say do a daily visual observation. We needed to time that observation with low tide, because that's when the critical lack of overburden, essentially, from that water weight acting on the discharge point would be present. And so if we went out during a high tide condition, obviously visibility is a little bit obstructed for one, but the internal erosion occurrence that we were trying to identify and make sure there weren't any more outcrops of just wasn't going to happen under those conditions. So we had to work with our inspection team to understand that you had to target this for low tide every day. Moving on now to improvements to portfolio management. This is really all about resource prioritization. And I think we can probably all agree that personnel and financial constraints are a bit at odds with the needs of our aging infrastructure. But by incorporating risk, that can help you determine how to best allocate resources for a single dam or across a portfolio of dams. And there's a couple good examples for this. So the first one, looking at how we can tackle risk associated with a single dam. So in the example I previously gave about the Australian dam, this is what the final plot looked like after we went through those additional studies. But we still had a little bit of a high risk profile associated with certain potential failure modes. And these are our risk drivers. And so as we were thinking about what would you do first, basically, how can you get the most bang for your buck by making improvements to the dam or to surveillance and monitoring program, we wanted to tackle those things that were at the top of the risk list. So that's an example of a single dam. A great example of a portfolio of dams is what the Corps of Engineers did with their screening portfolio risk assessment. So that process was completed a few years ago, and through undertaking that screening level risk assessment for all the dams in their portfolio, they were able to understand relative risk, assign an initial classification. So in this case, DSAC 1 through 5. And now they're able to work to address the highest risk ones first. So those that are DStack 1 through 3 and occur in kind of this upper part of the matrix, that's where they're targeting their activities, because it's a way to have the greatest initial improvements in reducing risk for the overall portfolio. So moving on now to business case support. I think the obvious one for when we talk about business case is having a better understanding of costs and benefits. And dam safety improvements, once we go through the risk analysis process and outline what can be done, those can be defined in terms of benefits to society or reduction in economic or environmental damages. So when I say benefits to society in this context, it means reduction in potential lives lost. And ultimately, this cost benefit number is a data point that can help decision makers make better decisions. But as we'll talk about on the next slide, it's not the only thing that matters. It's just a data point that fits within your overall decision-making framework. So an example to help demonstrate this, again, back to that Australian project, I showed you the final cumulative risk plot where we still had risk plotting above the limit of tolerability. So we had to do something. And working in a workshop setting with the client and other stakeholders, we identified a number of alternatives that could be done to address not only the risk driving failure modes, but all the failure modes that had been identified. And then we grouped those into programmatic approaches that we called risk reduction options that would essentially, in order, target the highest risks and then sort of grow to include other risks that were still considered for the dam, but maybe weren't leading the list. Once we had those programs established, we developed conceptual designs and put together opinions of probable construction cost. And that gave us an idea of what the cost for implementing each of those options would be. And ultimately, we came up with 6 options that were vetted through this process. And we were able to take those, and there's a lot of different ways you can visualize cost benefit. This is one way we elected to do it here. But the darker line up on top is representing your reduction in potential loss of life in terms of orders of magnitude versus the baseline. So with each risk reduction option, we're reducing our annualized potential loss of life value. And then the blue line down at the bottom is representing the annualized cost of implementing the risk reduction option. And so in this approach, we can see that around risk reduction option 4 is where we sort of hit that sweet spot of diminishing returns. So when we go from 4 to 5, we're no longer seeing any real significant reduction or improvement in benefits to society. And we have increasing cost. And so this is, from a cost benefit standpoint, an item that factored into our overall assessment of the options from which the client was able to make a decision about path forward. So the last item under business case support is that it's important to remember that dam safety risk is part of asset management. And for utilities, whether they're energy utilities or water utilities, it can sometimes be difficult to equate dam safety risk with, say, loss of generation or loss of water supply. The cost of those outages are, I'm sure, a very well-known number in your organization. And it's pretty typical to do what's needed to try to avoid unplanned outages as much as possible. Well, when we think about it from that perspective, a dam failure or even a dam safety incident, Oroville's a great example of that, where it wasn't a failure, but it was a very significant incident that affected their ability to operate that project as intended. That's an unplanned outage that is going to take you considerably more time and cost to recover from. And so the challenge we face as dam safety practitioners is trying to put the dam safety risk into a similar context as other asset management concerns. So, say what you need to, the routine maintenance you need to do to keep a generator operational. Things where we have known time to failure parameters, and try to frame dam safety in that same regard. When we are able to try to make those links, and it's not perfect, it'll always be a little bit apples to oranges. It really does help when trying to communicate investment decisions to the decision makers. And so that allows us to take O&M activities that directly relate to, say, a risk driving failure mode, and perhaps give them precedence within an overall enterprise asset management system. And so through that approach, we can try to avoid the occurrence of an unplanned outage and, think about dam safety from almost a preventive maintenance philosophy. Ultimately, the water that's being retained by the dam is critical to hydro generation, to your water supply systems. And so, it's not enough to just keep the moving parts moving, but we have to keep that static stationary dam asset in good condition as well, so that it can continue to be reliable for our storage. And so let's quickly revisit the answers to the questions I asked at the beginning. So you had three choices. The first one was, I lost it. The first one was, does risk scare you? And, do you know anything about it? That had pretty low responses. Those that, I think the second response was asking whether you've heard about it, but you're still a little bit unsure. I think that had about 40 or 45% response. And then the last category was asking whether you've implemented some form of risk informed decision making, and that bucket was actually a bit higher than I was expecting. So that's great to hear. There's a second poll up right now, and I wanted to just pose this final question to you before I summarize some of the key takeaways. How do you feel about risk now? Are you still scared? Do you get the gist of it, but you're still a little bit unsure? Do you see why it could be beneficial and you're looking forward to opportunities to incorporate it? Or are you even more encouraged that risk-informed dam safety decisions are a good thing? Key takeaways from today. If you forget everything else, I hope you remember these three things. The first one is that traditional engineering standards are intended to be integrated within the risk assessment framework. We're not abandoning our history of dam safety engineering by transitioning to a risk model. We're simply improving upon it and enhancing it to kind of better incorporate engineering judgment and all the great experience we've learned over the history of dams projects now. The second one is that the outcomes of a risk analysis can help you operate and maintain your dam more efficiently. So we talked about perhaps improvements to surveillance and monitoring programs. We talked about from an asset management perspective, how can you target O&M items to those key risk drivers. So the idea behind this one is that we we understand that our resource pool is limited, and that resources include both dollars and personnel. And we're all stretched more than ever these days. So being able to be efficient is really important to improving the success of our dam safety programs. And the third one is that risk doesn't have to be scary. It's just another piece of information that can help you make better informed decisions. Again, it fits within that overall decision-making model, but the onus is still on us to put our thinking caps on and make decisions that are best for our organizations. And risk is just a data point to help us get there. So before I move on to the questions, we'll just review the answers to the last poll. A couple of you guys are still a little bit scared. A few of you get the gist of it now, but you're still a little unsure. About 38% see why it could be beneficial. And it's great to see 56% of you think that you're even more convinced about using risk-informed decisions. So hopefully this helped you kind of package those benefits into a more structured thought process, and you'll be able to leverage risk-informed decision making for your dam safety programs. So with that, I would be happy to open it up to questions.
All right, great. Thanks, Rachel, much appreciated. We do have a few questions that are coming in here. First one is probably one you may hear often. I'll just summarize it, but what are the schedule and cost implications of a risk-informed process versus a more traditional process?
It really depends on the level of risk analysis that you're going to go after. So, fundamentally, I think everything that goes into a risk analysis process are things that, if you're proceeding within a well-structured dam safety program, you're going to ultimately do at some point. The difference may be instead of doing a PFMA, you're now doing a risk analysis workshop, which is a little bit more effort, takes a little bit more time, but you're able to structure those activities and have a workflow of those activities that allows you to get the most important answers first and be able to prioritize actions associated with those most important answers. But yeah, cost and schedule are variable based on exactly what you're trying to achieve from that process.
Okay, makes sense. There's a couple that are kind of similar. I'll start with maybe the more specific one. Do you know if Ferc is moving towards requiring risk-informed decision-making as part of the 5-year independent consultant review?
They are. So I think it was last summer, Ferc issued their draft policy on risk-informed decision-making and outlining what their proposed approach to incorporating risk analyses within the independent consultant process would be. They solicited public comments, and many organizations, including Stantec, provided some commentary on that. They're still working through the comments, is my understanding, and trying to incorporate those before they roll it out. I believe they are, though, beginning to notify different utilities that potentially have would be in line to incorporate a risk analysis within their next Part 12 inspection. That's likely coming up for them, so they can kind of start planning around it. But the idea behind those regulations is that every other Part 12 inspection, so once every 10 years, you'd be required to do a level 2 risk analysis, which is somewhere between a PFMA and a semi-quantitative analysis.
Okay, great. And I think that there's additional questions and kind of related to that same type of thing. How do you, what do you see in terms of regulatory bodies accepting this process? Are some requiring it, or others more concerned about it and want you to stick to more traditional methods, et cetera? But is maybe your answer for the first question was probably sufficient for that, huh?
Well, I can add to it a little bit if you'd like.
Sure.
So, I think obviously in the US, we don't have a national regulation. We're regulated at the state level by state dam safety programs. And then our federal agencies, so the Corps of Engineers, the Bureau of Reclamation, Tennessee Valley Authority, and then, Ferc isn't an owner, obviously, but they are a federal regulator. All of those agencies have adopted risk-informed decision-making in some capacity. So Bureau of Reclamation is probably the most mature of those, and they've been working through this process and implementing it for roughly the last 20 years. The Corps of Engineers is pretty close behind them. And then you have kind of Ferc at the other end of the spectrum that's just trying to put a framework around it that can be adopted by their utilities. So generally what we see, trends we see in the US are that, as the federal agencies go, so go the state of the practice. So, I think as we look over the next 5 to 10 year horizon here in the US, we will see risk being adopted more broadly, even if maybe you don't fall under one of those umbrella regulations. There are some states that have already adopted risk frameworks as they evaluate dam safety. Colorado is a great example of that. And then you have other federal partners like FEMA that, as part of their high hazard potential grant program, are requiring applicants to go through a risk analysis like process, look at cost benefit. And so, you're seeing samples of risk kind of being embedded into these different locations.
Okay, great. All right, so another question here. This is can this approach work well for flash flood regions where maybe floods happen every 5 to 7 years only, and maybe a client says, well, we don't see a need for this?
I think so it's all about hydrologic uncertainty then when it comes to flash floods. So you can definitely adopt a similar process. And, in fact, the Corps of Engineers with their levee screening tool, levees are well known to be susceptible to flooding. And so, with that approach, they're looking at risk associated with levees. So, I think there's some great examples out there, but when you think about flash floods, you're dealing with a lot of hydrologic uncertainty. I'm very quickly getting a little bit outside of my wheelhouse if we get into hydrology, but you can adopt the same principles and the same processes. You may just need to consider the hydraulics and the hydrology a little bit differently with that specific application.
Okay, yep, that works. How do you convince policymakers to accept a risk-based decision-making process?
Communication. I think as we see risk being adopted more and more as our state of the practice, it will become easier and easier. But I think that there's a lot of great examples out there that have demonstrated that you can still get acceptable societal outcomes by incorporating risk. There's a great example that Stantec actually was a part of, upgrades to the spillways at 2 hydroelectric facilities in northern Indiana. And this project went through a risk process, I want to say about 10 years ago or so. And it was one of the first risk projects that occurred underneath a Ferc regulated facility. And the issue there was that the spillways were not compliant with the PMF, so the probable maximum flood. And, it was going to be essentially an unacceptable financial investment for the owner to be able to upgrade those facilities to that condition. They were instead going to need to look at actually decommissioning. And so working in collaboration with the owner and with the regulator, we went through a risk-informed process to come up with an acceptable flood capacity for a spillway upgrade. So it still got upgraded, but taking into account hydrologic probabilities to inform what a more reasonable level of upgrade would be. But it's a lot of communication, and it's a lot of bringing people along in the process. So it's not just something that happens behind a curtain and here's the answer. Like with any sort of stakeholder engagement and buy-in, having people invested throughout the process, I think is really one of the ways you can be most successful with it.
All right, good. All right, next question. Could you give us a recommendation to align the risk assessment with the ALARP and the real risk? We know that dams are critical structures, but if we work with high risk, we could impact the projects. I don't know if that means other projects or exactly what they mean there.
Yeah, and I'd be happy to follow up with you, Anna Maria, on this in particular if you have something in mind. But so I didn't really go into it, but ALARP is the concept of as low as reasonably practicable. So when we consider dam safety improvements that are geared towards reducing risk, there's this idea that we're trying to achieve risk reduction that is as low as reasonably practicable. So you're not trying to eliminate all risk, but you're trying to basically hit that sweet spot where you're fulfilling your obligations to society as an owner. And so the risk assessment directly feeds into that ALARP process. It sort of the analysis piece of it provides that numerical input to understanding what the risk is. And then through the ALARP process, we can capture other details that may influence the ultimate decision. These could be operational concerns. These could be regulatory concerns. It could be understanding from a societal standpoint what effects may or may not be acceptable. Maybe there's a sensitive cultural or ecological area that we may not come out in the risk assessment process, but we know it's there and we need to try to avoid impacts. So the ALARP process allows us to build in some of those more qualitative thoughts and provide context around the numbers for decision makers.
All right, thank you. Okay, next question. What's the biggest challenge in implementing the risk-informed approach as an integral method?
I think where we are right now, it's really just the socialization of the approach. So helping people get comfortable with how to go about it, what the results mean, the idea of tolerable risk, and as an organization where you may draw your line for what you can and can't accept, I think is a question that is really hard to grapple with. There's obviously some generally accepted limits out there based on what's been adopted by the Corps and the Bureau of Reclamation and other international regulators. So I think from an organizational perspective, that can be a challenge. From a consulting perspective, the trend is moving towards risk, and so as we see more and more owners and agencies adopting risk as part of dam safety management, as an industry, we're working feverishly to make sure that we have the right people who have been properly trained to actually implement these approaches. There's a lot of good opportunities to incorporate risk right now within the industry, but it's important to work with folks that understand the principles and understand best practices to help you get where you want to be. There's a lot of go-bys for how these programs can be structured, but being able to tailor something to how your organization functions is really critical for it to be adopted as a way of thinking within the organization.
Okay, thank you. All right, we got a few minutes left. I'm actually going to allow the attendees to unmute themselves. If you'd like to have a follow-up on one of your questions, or maybe comment live here, or just ask a question, you can unmute yourself now if you'd like to do so. Sometimes that can lead to some good discussions when we have a couple of minutes left. Also, continue to use the GoToWebinar function if you have more questions as well. And if we don't have anything else, we can always give you back a couple minutes in your day. I did put a link to Rachel's contact information on our website in the chat. If you have questions you'd like to follow up with her on directly or follow up on a previous question, feel free to just contact her via email, or her phone number's on the website as well.
Great. Well, thank you everybody for your time and attention today. I hope you learned a little bit at least, and I'd be happy to follow up afterwards if there's any other questions.
Yeah, agreed. So let's end it there and say thanks to everybody that joined. Really appreciate it. And again, look for that certificate of attendance in a week or two, and then the recording will be posted on the website around the same time. So with that, I'll say I hope to see you on a future webinar, and I hope you have a good day. Thanks, Rachel.
Thanks, Ryan.